The first target learning objective for this lesson is how does the moon cause changes in tides? So if we were to look at Earth with no moon, notice that there is equal amount of water throughout the globe. Now when we have the moon, notice now that there is a bulge, okay? So again, this is Earth with no moon, and then this is Earth with the moon. So because of that gravitational pull, that's going to cause the water to rise in certain locations and fall in other locations. So this is called a tidal bulge. Tidal bulge is created by the gravitational pull of the moon on Earth's water. Tides change because of Earth's rotation and moon's revolution. So tides change throughout the day because we're rotating, and then tides change depending on the moon's phase due to moon's revolution. There's approximately 12.5 hours between two high tides, so there's going to be 2 high tides a day and 2 low tides during the day. This is a recent data chart of the tides. Notice that the tides on each day, they have the time of the high tide, so there's 2 high tides and then there's 2 low tides. Notice that the time is about 12 hours apart, from 6:43 to 7:02, and same thing from 1:20 to 1:59. That's about 12 hours as well. From high to low, it's about 6 hours. So every 6 hours, the tide changes. So it's from high to low to high to low. And then depending on the phase of the moon is also going to change the height of that high tide. So notice that the height of the high tide on the 14th, when it was a new moon, it was the highest high tide, 1.6, and it was the lowest low tide, 0.2. So one cool location is the Bay of Fundy, which is in Nova Scotia, Canada. So we're going to watch this video, and this is an example of an extreme high tide and low tide. So this is a time-lapse video, so it's sped up, but you can see what's going on. The tide is high, and then it gets extremely low. So wherever the moon is, that's going to determine where the high tide is. So if New York is located here and the moon is out, that's going to be where the direct high tide is. On the other side of Earth, they're also going to have a high tide. And then perpendicular to the location of the moon, they're going to have low tide. So notice that there's this bulge. Obviously, the one closest to the moon is going to be the higher high tide. So this is going to be a little bit higher than this one, but both of these locations are going to have the high tide. And then as Earth rotates, then New York will rotate here and it'll have a low tide. It'll rotate here and get an indirect high tide. It'll rotate here and get another low tide, and then it will repeat. So this is an example of when the moon is directly where our location is. So this is an example of Jones Beach. Notice that the water is high up. Now, if Earth rotates, now New York is away from the moon. Now there's going to be a low tide because it moved away from the tidal bulge. So see, the tidal bulge didn't change, just Earth moved out of it. And now notice if you're on Jones Beach, now the water is now below the umbrella, okay? So that's how the tide moves in and out. So that would take 6 hours about from going from high tide to low tide. So how does the moon and sun create special tides? So because the moon is revolving, there's going to be times when we're going to have extra high tides and extra low tides. And then there's going to be times when the difference between high tide and low tide aren't very different. So what is a spring tide? A spring tide is when the sun and the moon work together. High tides are higher and low tides are lower. So there's a more extreme tidal change. So there's a bigger difference between the high tide and the low tide. So a spring tide occurs when the sun, the moon, and the earth are in lines in a straight line. So the way to remember the spring tide is that it's a straight line, and spring and straight both start with an S. So notice that they're all aligned. They're going to have the direct high tide here, indirect high tide here, and they're going to be the greatest high tides and the lowest low tide, the biggest difference between high and low. Another location for a spring tide is when the moon is on the opposite side of Earth. Again, the sun, the earth, and the moon are in a straight line. So again, we're going to have the highest high tides and the lowest low tides. So an example of when this occurred is Hurricane Sandy. So during Hurricane Sandy, because there was a spring tide full moon, and because the moon was at perigee, it's also going to affect the tide. We had extremely high tides in this time. So that's why Hurricane Sandy, especially in New York, caused a lot of damage. And that's because there was a lot of flooding because the water rose, and it was because of the moon's phase. So if the moon was in like a waxing crescent or in any other phase other than a new or a full moon, the storm wouldn't been so extensive. So because it was a full moon, that caused it to be a lot more damaging than it could have been. A neap tide is the opposite. So this is when the sun and the moon are working against each other. So there's going to be the least difference between high and low tide. So this occurs when the moon and the sun and earth kind of make a perpendicular or a right angle. So notice that the moon is here. This is when we would be in like first quarter or third quarter. And notice that the direct high tide's here, indirect high tide's here, and then on the other side, there's going to be the low tide. Another way we could have a neap tide is on the opposite side here. Okay, so it could be here or here. Again, high tides are when they're in line. The low tides are going to be on the opposite side. So that is all you need to know about tides and the moon.